Assalamu alaikum warahmatullahi wabarakatuh. Back to our topic, that circles for class 10th. I will try my level best to complete this chapter in this lecture. In last lecture we discussed about the secant and the tangent, and we also have done a theorem regarding the tangent and the circle. Couple of points I want to mention here, that is how many tangents a circle can have. The first point here I mention it here, a circle can have infinite number of tangents. एक सर्कल को कितने टेंजेंट्स हम डाल सकते हैं? एक सर्कल को हम जितने टेंजेंट चाहे उतने डाल सकते हैं. जैसे मैंने यहाँ एक टेंजेंट डाला, यहाँ एक, यहाँ एक, यहाँ एक, वैसे ही आप सर्कल्स में कितने टेंजेंट्स डाल सकते हैं? You can have infinite number of tangents to a circle. That's one point. Second point, how many tangents can we have at a point of contact? कि point of contact पे हम कितने tangents डाल सकते हैं? We can have only one tangent at the point of contact. That is, point of contact, the intersection between the circle and the line. That is second point. And the third point, very much important for in this in third point, that is how many tangents can we draw from a point lying outside of a circle. कि हम कितने tangents डाल सकते हैं एक सर्कल को, और वो पॉइंट कहाँ लाई करता है? सर्कल के बाहर. Here two tangents only to a circle through a point lying outside of the circle. कि हम उस पॉइंट से, जो पॉइंट सर्कल के बाहर है, कितने टेंजेंट्स डाल सकते हैं? वहां से हम कितने टेंजेंट्स डाल सकते हैं? वहां से हम 2 टेंजेंट्स डाल सकते हैं. नाउ द इम्पोर्टेंट थ्योरम regarding this tangent, that is theorem 10.2. That theorem is the lengths of tangents drawn from an external point to a circle are equal. That is, we have to prove the tangents drawn from an external point. How many tangents we can draw from an external point? That's 2, we know that, but we have to prove that these 2 tangents are equal in length when they are drawn from the same point, and that point lies outside of a circle. That's what we are given. Here we are given a circle with center O and 2 tangents PQ and PR. What we have to prove? We have to prove that the length of tangent PQ is equal to the length of tangent PR. For that purpose, what we are doing, we join OQ, OR and OP. Since we know OQ and OR are the radius, and we know the relationship between the radius and the tangent, that is OQ is perpendicular to the tangent PQ and OR is perpendicular to the tangent PR, because OR and PR are the OR is a radius, PR is a tangent, OQ is a radius, PQ is a tangent. We have to prove that in this theorem. Since we know OPQ is a right angle triangle, here we are using Pythagoras theorem. And one more thing, we also know that OQ is equal to OR, radii of same circle. Now, by using Pythagoras theorem in triangle OPQ, here OP is hypotenuse, OQ is perpendicular, PQ is a base. Here I have write down OP square is equal to PQ square plus OQ square. And by taking OQ to this side, we will get PQ square is equal to OP square minus OQ square. OP square minus OQ square. Since OQ is equal to OR, they are radii of same circle. That's why I have write down here PQ square is equal to OP, and in place of OQ square I have write down here OR square, as they are equal. Since OP square minus OR square, for this triangle OP square, that is hypotenuse minus perpendicular, that will be equal to base Pythagoras theorem again, PR square. That means in place of OP square minus OR square, I have write down here PR square. PQ square is equal to PR square. Square square cut. We will get PQ is equal to PR. In this section, we have completed the second theorem of this chapter, that is circles. Here I have done